So today we start the process of solving a quadratic. And so there's a few different methods that we're going to use to do that, but we're going to start today with the graphing method since we just learned how to graph a quadratic. So there's a couple terms that we do need to look for. So when we're solving a quadratic, you might hear that solution called a few different names. One of the names that they use is called a quadratic root. And all that it is it is the x-intercept or intercepts, because remember there could be more than one, of the parabola. And we also call these zeros, of course, x-intercepts, or solutions. So the solution for a quadratic can basically goes by several names. It's an x-intercept, it's a root, it's a zero, or it's a solution. And you'll see those words used interchangeably when we talk about quadratics. So the second term that we need to talk about is the discriminant. So first off, discriminant is d equals b squared minus 4ac. And hopefully that b squared minus 4ac looks pretty familiar to you. But in terms of solving quadratics, this is the formula used to determine how many roots a quadratic function will have. And of course, we know that it is also used for the factor test. And so that's where it's going to be looking familiar from. So we used it for the factor test when factoring trinomials. So just as a kind of a reminder there. But this is the discriminant. It's the formula used to tell us how many roots the quadratic function will have. We used to use it for when we factor trinomials to tell us how if it could be factored. Now it also tells us how many solutions that a quadratic will have. Okay, so the discriminant, we call it D. It tells us how many solutions that we're going to be looking for the quadratic, and to find it, we are going to substitute our a, b, and c values from the standard form trinomial into the formula. Remember, the formula is b squared minus 4ac. And we are going to simplify. Okay. Now, one way that we find the roots of a quadratic function is to graph the function, and we're going to find the x-intercepts. Remember, we can call those solutions, roots, x-intercepts, or zeros. Now, there are three potential categories that solutions can fall into. There's going to be two solutions. That's going to be where the parabola crosses in two places, crosses that x-axis. There's going to be one solution where it only touches one time, and there's going to be no solution where it never crosses the x-axis. Okay, so a couple of examples here just to look at. So we look at this example here, and we notice that our parabola crosses in two locations. It crosses at -2, 0, and at 2, 0. So this is going to be an example of a two-solution graph. Now, in these cases, our discriminant value would be greater than 0. Any number, then we're going to plug that into our formula, and we get a number greater than 0. We're going to know we have two solutions. Now, when we write our solution answers, we're going to take just the x value of our solutions. So we end up going from least to greatest, and we write that as -2, 2. Alright, then we have this example here, where you notice that it only touches in one location. It stops at 4, 0. So this is an example of one solution. And our discriminant would be equal to 0 in that time. And so here, we only have that x is equal to 4. Alright, and then our final solution over here, final example here, we notice that it never crosses. This parabola continues on forever, but it never crosses this x-axis. And so in this case, there is no solution. And these are when our discriminant is less than 0. A negative number is going to be a no solution. And so our x is equal to no solution here. Okay? So we're going to do a quick example together just to kind of walk through this process. So first off, we need to find the discriminant to find out how many solutions we're going to be looking for. Then we need to graph it like we've done before and find the root. So here's our equation, x squared minus 6x plus 5, and we're going to look for our discriminant. So first off, a is 1, b is -6, and c is 5. So what we need to do here is plug those values in. So we have b squared, negative 6 squared minus 4 times 1 times 5. And when we simplify that, we get 36 minus 20, which is 16. So here we have a discriminant of 16. Now that number is greater than 0, so there should be, looking up here, greater than 0, 2 solutions. Okay. So now we need to find our axis of symmetry and our vertex so that we can plot the points on our graph and graph this problem. So we're going to do axis of symmetry. So we have a negative b, and our b value is negative 6. So remember, our value of b is negative 6, but the formula is negative b. So that negative here is from the formula. This negative is from the value of b. Divided by 2 times a. In this case, a is 1. So we end up with 6 divided by 2, which is 3. So our axis of symmetry here is 3. Now, we know that with our vertex, it lands on our axis of symmetry, so our x value for our vertex is 3. So now we just need to find the y value. So we can take and find any y value from our formula if we plug the x value in. So I'm going to take this formula, y equals, and in place of the x, I'm going to put parentheses, and I'm going to replace that x with a 3, because that's the x value that we want the corresponding y value of. So then I simplify, I get 9 minus 18 plus 5, and when I simplify that all the way, I get negative 4. So my vertex point here is 3, negative 4. So that's what I'm going to put here in the middle. X values I need to look for is 1, 2, 3, 4, and 5. And I'm going to use my calculator here just to find the rest of those values. So once I plug that in, I'm going to go to the table, and I notice that the 1 is 0, 2 is negative 3, 3 of course is negative 4, 4 is negative 3, and 5 is 0. So we're going to go ahead and plot those points. So I end up with 1, 0, 2, negative 3, 3, negative 4, 4, negative 3, and 5, 0. And we can go ahead and sketch that. So what we notice here is that I have an x-intercept here, and I have an x-intercept here. So those are going to be my solutions. And I notice that the first one is at 1, 0, and the second one is at 5, 0. So when we go to write our solution, we're going to write them as a solution set. And so we just use only the x values here. We only want to use the x values when we're writing our solution. So it's going to be 1 and 5 are my solutions for this quadratic.